Hello, and welcome to Speaking of Psychology, a podcast produced by the American Psychological Association. I'm your host, Kim Mills. Speaking of Psychology is a podcast for anyone with an interest in the science of psychology. We talk to psychological researchers, practitioners, and educators about any and every aspect of psychology and its application to the world around us. Dr. Jeff Hancock is founding director of the Stanford Social Media Lab and a professor in the Department of Communication at Stanford University. Dr. Hancock works on understanding psychological and interpersonal processes in social media. His research team specializes in using computational linguistics and experiments to understand how the words we use can reveal psychological and social dynamics such as deception, trust, intimacy, and social support. Dr. Hancock is well known for his research on how people use deception with technology, from sending texts and emails to detecting fake online reviews. We're fortunate to have him here today with the American Psychological Association. Welcome, Dr. Hancock.
Thank you, Kim.
So I wanted to start by talking a little bit about social robots and your work in that arena. The first question is just to explain for the audience, what's a social robot as opposed to any other robot?
Right. Yeah, social robot is really broadly defined. Basically, any robot that's situated with humans. So a couple of definitions are that they should be socially evocative, sociable. So any robot that's designed to essentially work or interact or evoke responses from humans.
So it's not a Roomba, for example.
Well, it's funny you should ask that. Roomba's a good question, and our group thought a lot about that. Sometimes a Roomba could be made into a social robot. You put some little things on it, and amazingly, people will really interact with that robot as if it's, interacting with them. But
Get that in the corner there?
Exactly. Yeah, come on, get that work done for me. But no, typically it's robots that are designed to interact with the humans. So it can be in workplaces. So factories now often have robots. And a number of them now have been sort of personalized, made to look a little bit more human, so that the workers around them can understand what the robot's doing, what its intentions are, where its attention is.
Mm-hmm. So talk a little bit about the research that you did. I understand you looked at the last decade of all the research that involves social robots. What were you looking for? What did you find?
Right. So the group I was working with was Byron Reeves and Sunny Liu, both at Stanford with me. And we had a group of 10 RAs work on this project where we looked at a decade worth of research on social robots, and it was fascinating and a lot of work. There was almost 7,000 articles that in Google Scholar that referenced social robots. And then we narrowed that down to about 1,400 that mentioned social robots, but then also had a robot interacting with a human or looking for some sort of social response. So there's been, over 1,000 articles on social robots, and it's across a dizzying array of disciplines. So psychologists, computer scientists, engineers, anthropologists. It's pretty amazing. So we looked at all of those across a decade, and then the thing we got really excited about was we found the photo of every robot that was in that decade's worth of work, and found as many photos as we could for each robot. And so we sort of had like a early census, if you will, of every social robot that had been published about. And it turns out there's 342 that we found over that decade. So there was sort of like one of the first collections of all social robots that's been put together.
And what were you trying to find by looking at that?
Well, my colleague Byron Reeves had this insight when we first started on the project, and one of the reasons I got involved. So I usually study things like social media, so how people interact through technology. But I remember having a meeting with Byron where he had this insight, which was that we can think of robots as media. And since they're social robots, it was like a form of social media. So I got really excited, and it was really my first big foray into working with robots, and it was all because of Byron's insight of thinking of them as media. And what follows from his insight then is most of the research on social robots looks at one robot at a time. There's good reason for that. They're expensive. Usually you've built a robot and you want to understand, how does this robot, evoke a response, or how is it effective at getting people to learn or to feel better if it's an assistive context. The problem with that, which we know from psychology, is if you're trying to generalize to social robots, studying one robot at a time is a real problem. This is a problem of stimulus sampling. And so in psychology, we've known about this issue for many, many decades, since the middle of the last century. And what Byron's insight sort of led to is that we need to get a big collection of these stimuli so that we can start generalizing across social robots as a category of social actor, rather than, well, does this robot do anything, or if we make this robot have an arm and versus no arm, does it do anything? And so that was what we were interested in, is getting this big collection together so we could start doing research on a population, a sample, if you will, of social robots, rather than one exemplar at a time.
And so what does this portend for the future? How will this be applied?
Right, that's the key question. And it's been exciting at this conference because I've already talked to half a dozen people that came up after the talk that were like, hey, we'd like to do this project or that project. What we've done is started by asking, well, now that we have this collection of robots and a collection of photos of them, when you look at them, and I can share a image with you to go on the podcast or website, it's astonishing how varied they are. I mean, even when we show it to people that are in the field and have been in the field for a decade, they're like, whoa, okay, these are really, really different. I mean, it's sort of like thinking, I could take you and study you as an example of an extrovert and then, generalize to all the extroverts, but we know that people are really different. Well, robots are even more different than different people. So the first question then is, do we need a whole new psychology to understand social responses to social robots? And the answer, when we look at the literature, is pretty clearly no. People tend to bring sort of standard social psychological processes to new media. So there's tons of work that shows that we treat technology kind of as social actors, and we bring our old brain, which has been evolving for a long time to understand social actors, like, is this a friend or a foe? We bring that to technology. So the next question then is, well, if we don't need a new psychology because people, sort of react and perceive technology the same way they do humans, what's a good place to start to look at, is there a fundamental dimension or two in which people perceive robots? When we looked at the literature in social psychology around person perception, there's a lot of evidence that people judge others along two dimensions, very quickly, automatically, and comprehensively. So their warmth and competence. And some of the main research on this are Susan Fiske and her colleagues, Amy Cuddy, for example. They've done a tremendous amount of work showing that over 100 years of research across cultures, people's initial perceptions of other people really boil down to warmth. So is this person going to be trustworthy, kind, warm towards me, or are they cold, perhaps threatening? And they argue this is an evolutionary question. Is this a friend or a foe? I need to determine that right away. And then another is competence. So does this person seem capable, competitive, strong, these sort of terms. And so we thought, let's start there. Let's take a look at that. And what we did is we had several thousand, over 3,000 Mechanical Turk participants take a look at a single robot and then answer a bunch of questions like, does this robot seem warm or cold? A bunch of those. A bunch of ones related to competence or not. And then we did what psychological researchers do. You factor analyze those to see if they resolve to some factors. And it's amazing, Kim, it's exactly the same as if we
just
showed
like
them.
people.
It's just like people.
So what makes a robot warm or cold?
Right. So that was our next question, exactly. Because designers are going to want to know this, right? Like, how do I make it warm or cold or competent or incompetent? Warmth, it turns out, is really driven by eyes. So does it have eyes or not? Which you wouldn't normally think of right away as
But they don't. I mean, Jibo doesn't have eyes, for example.
Right, exactly. So there's this, that's a major thing. And not only anything about eyes. So once you have eyes, that's a big predictor. Then it's the ratio of the eye size to your head size. And There's lots of evidence that this is about warmth too. So Disney characters, for example, tend to have really big eyes relative to their head.
Yeah.
So that's a really huge factor. And then in terms of competence, it's the lack of fur. So if you can see the mechanics, like steel and, actuators and stuff like that, they're going to actually appear more competent. If there's fur, they're going to appear less competent. And then mobility is a big one for competence. If that thing can move around, whether it's, arms or moving around like that, then there's more competence. And so it's amazing. And it actually has really fascinating and potentially disturbing implications. So Fisk and her colleagues have this model called the stereotype content model. And they say with warmth and competence, you can kind of predict in this 2D space stereotypes. So competent is up in the right. Those are people that are, warm, high competent. And that's the default in-group. So when they were doing their research in the early 2000s, late 90s, this would be like white middle-class America. So if you ask Americans at that time, the default group, the high competence, high warmth, that was white middle-class America. Then you go down into the lower space where it's high competence, low warmth. These are like engineers, rich people. And these people are, they evoke a different kind of emotion. So it's envy, right? So and a little bit of, so you admire them a little bit, but it's more like a little suspicious. So they evoke this envy thing. Whereas the default group evokes like admiration and positive emotions. You keep going around, so you're down in the low space, and stereotypes down there would be poor people. So this would be poor white, poor black, homeless, people on welfare. And they evoke a different kind of emotion as well, which is contempt. And so you keep going around, you get up to the high warmth, low competence. These are people in the 90s would be like housewives, people in that sort of space, mentally handicapped individuals, so again, these are stereotypes.
Yeah.
And the emotion evoked there is pity. So as a designer, if you're designing a robot with these different features, unbeknownst to you, you could actually be causing an initial emotional response that is deep-seated in our psychology. Yeah.
That's pretty interesting.
Yeah, we thought so.
So did this research tie in at all with the work that you're doing on deception?
Yeah, so now we're doing a bunch of things about like trust of robots. So how much would you trust this robot? And the initial work there is, warmth is going to be a big predictor of that. Your sense of its status. But then we'll need to move it into different kinds of situations. So I might trust Jibo in an interpersonal interaction where we're just having a fun social interaction. But I might not trust Jibo if I'm on the battlefield and I need a robot to help me find bombs and defuse them, right? Mm-hmm. So situations are going to play a really huge role, and our collection of photos really is in sort of a totally neutral, like there's zero context. So that's the next step. But yeah, I'm really interested in deception with these robots. One of my favorite examples of deception with technology wasn't a robot, but kind of similar, and that's the Volkswagen scandal, where they programmed their cars to lie to investigators who were looking for like how much pollution it would produce.
Right.
So it's fascinating. This car, when it figured out that it was being tested, changed its behavior, right? Like it would literally have less power but produce fewer emissions, and not one car, millions of these. And programmed to lie to humans. And so, it's really fascinating. And so
the engineers used robotics when they were developing this?
Well, we don't know that, but we can kind of think of the car a little bit like a robot, right?
Yeah.
It's a technology that it wasn't making its own decision. It was programmed in, but it was programmed by humans to lie to humans via, its sort of technology. So, right, what's going to happen with robots? We've seen some autonomous robots that have learned to lie. So these are small little robots, and their job is to go around and find food. And they're competing with other little robots, and the food is like a little electrical charge that they get. And they are given some artificial intelligence, so they're trying to find food but not let their other robots get the food. And these robots would learn to lie. They would go to an area. Once they found where the electricity was, they would then go to another area and buzz around there. And then other robots would come. And when they all came there, it would zip out. And we see this with animals. Like crows are very good at doing deception. So a younger male crow that will get beat up by the higher status crow will pretend to find food somewhere, and then when all the big crows come, it goes off to where the food actually is. So we're seeing humans using technology like robots to lie to other humans, and we're seeing some of the very earliest evolution of deception in these sort of artificial intelligence systems.
Well, were those robots actually programmed to learn deception? So they were
given these constraints and objectives, and the objective was to get as much of this food, their electricity, as possible, and that they were competing with these other robots. And so from that, they learned that deception was a good tactic to do. And we see this with non-physical AI, so things like chatbots, conversational AI. In a negotiation game where they're negotiating with another human, or with a human, or with another AI, we saw that deception, that same kind of idea of deceiving, evolved in that as well. So it's pretty clearly an advantageous evolutionary strategy. Once you're able to communicate something that isn't necessarily true, then deception becomes a strategy for achieving your goals. It comes with risks, so if you're having a one-off interaction with another person where you're trying to get goods from them, then deception can be very useful. But over the long term, deception has been shown to not be necessarily the best strategy. So,
are we moving in any particular direction around the design of robots? I mean, I'm thinking, are they going to become more human-like, less human-like, or does it really depend on the context?
Yeah, I mean, that's a really great question. And I think Justine Cassell, who did the keynote yesterday, I think sort of like re-asked that question, which was, it's not about what the robots or these conversational agents and their humanness necessarily, but rather about our humanness. And so she really put this into this concept of intersubjectivity, which is when I feel like I'm engaging with the technology and I'm doing that as a human and I'm having a very human interaction, then whatever that agent is a success in that regard. So it's about creating a sense of intersubjectivity. And I thought that was a really nice way of asking the question, because then they can be human, like, and they can be machine-like, but it's going to be about how that sort of dyadic interaction works. So I think it's, one of my intellectual heroes is Herb Clark, who's also at Stanford, and his work shows that a lot of conversation and interaction communication is really tightly coupled. It's a joint action. So what we're doing right now is very joint. So we're nodding at each other and we're agreeing and smiling at the right time and looking. And I know I'm in a very human activity, right? This is amazing joint activity of communication. And so that's what's going to matter, I think, with robots and with AI type technologies, is the degree to which they're coordinating with us and building up that intersubjectivity.
So they could look kind of artificial, still machine-like, and still relate to them in a warm way.
Right. Cynthia Brezel's Jibo, and she gave the first keynote here, doesn't look human at all, but people really react to it, right?
Yeah. The video she showed was amazing.
It's very evocative, right? And they're having this pleasant and intriguing and surprising kind of interaction, and there's zero appearance of humanness, but Jibo has this ability to sense and respond in a way that feels very evocative. And it's kind of like, people love dogs, right? And they don't look human at all, but people form these really deep bonds with them, and it's because of that sense of intersubjectivity.
Yeah. Well, it's very interesting. Well, thank you so much for being with us today.
My pleasure, Kim. I really enjoyed it.
Speaking of Psychology is part of the APA Podcast Network, which includes other great podcasts such as APA Journal's Dialogue, about the latest and most exciting psychological research, and Progress Notes, which discusses the practice of psychology. You can find all APA podcasts on iTunes, Stitcher, or wherever you get your podcasts. You can also go to our website, speakingofpsychology.org, to listen to more episodes and see more resources on the topics we discuss. I'm Kim Mills with the American Psychological Association, and this is Speaking of Psychology.